Hello, team. Welcome back to another video. This is my this is video 328 of my 2,700 part series on math as we know it. Video 2,700 is slated to be released 20 years after my demise. I'll get my production team right on it. Thank you. Let's go ahead and pick up where we left off with transformations. They are more than meets the eye. So let's begin with day 2, transformations. Right with me now. Get your packets out. Let's do this as a team. We're a team. Don't let anyone tell you otherwise. We're going to do some graphs first. So we did some absolute value graphs. We're going to get warmed up with these. And yeah, I'm just going to work through it. And then we're going to remove the absolute value from the equation here. So let's do some warm-ups with stuff we did last time. Hopefully this will be helpful. Let me switch to the old pen. I'm feeling green today. Green. All right, remember our parent function, the absolute value of x, looks just like a V, right? Let me make sure I got my pen selected here. We writing? There we go. It looks just like a V, absolute value of x. Here we go. So you got a V coming up. It's really just looks like the line y equals x, but then you got a line coming up this way as well. That's what we got going on with the absolute value of x. That's the parent function, right? But the graph that we're doing here, the absolute value of x plus 4, is the parent function shifted to the left, 4. So all we do is we take that little V shape, and we're going to take those points and shift everything to the left. I knew it was to the left because it's inside the brackets, and inside behaves the opposite that you would think. So if you add 4, it's really like shifting to the left 4. Okay. So then you can kind of put these dots right here. So it's got the same exact shape as the parent function. So we can draw our graph up this direction. That continues forever, just like that. This one continues up this way, like so. Okay, let's pick up where we left off here. So there we did our y equals the absolute value of x plus 4. Let's change our color. We're going to move right along, and we're going to do the absolute value of x, or the opposite, so the negative absolute value of x plus 5. So we have two transformations that are happening here. This, remember, was a shift left 4 units. This has two different transformations. So the a value in this case, or the thing that's multiplying on the outside of the absolute values, is a negative 1, which means the 1 tells us it's the same shape as the parent function. The negative tells us that it's been reflected over the x-axis. So this is a reflection over x-axis. Students often ask, they say, hey, Mr. Slagle, that's what they tell me, and they say, which happens first? Do I shift? Because this is a shift. It's on the outside of the brackets, or outside of the absolute value. So this is going to be a shift up. So they say, Mr. Slagle, do I do the shift? Do I shift it up 5 first and then reflect? Or do I reflect, then shift it up 5? And this is what I tell them. I'm going to tell you what I tell them. I tell them you need to follow the order of operations. If you were to plug a number in for x, what would happen? Well, first thing you would do is you'd take the absolute value, and then you'd make it negative. Since that's the first thing that would happen, this is multiplication by negative 1. Order of operations states the multiplication has to happen first, right? That's going to happen, then you'd add 5. So the reflection happens first from the parent function, then we shift up 5. Simple. Simple. Okay, so let's do that. Remember, our parent function is just this v that's coming down here. So the first thing I'm going to do is I'm going to kind of draw my parent function in, just so we know what it looks like. Remember, parent function is looking like this. Got that V shape. So step 1, so I'm going to kind of do this in stages. Those dots continue. but this is y equals the absolute value of x. Now I'm going to take those dots. I'm going to take those dots from my parent function. I'm going to flip them over the y-axis. So now we're going to graph y equals the negative absolute value of x. So I'm going to take all these points. I'm going to reflect them. This one doesn't get reflected because it's on the x-axis, right? Whoops, that's not right. Try that again. I'm going to reflect them over the x-axis like so. And those continue, even though going down like this. Now I'm still not done, because now I got to take this reflected graph and I got to shift it up 5. So now in green, I'm going to put my final answer. Right, we're doing this baby in green. I'm going to take all these points. I'm shifting them up 5. 1, 2, 3, 4, 5. And I just use that as a reference point. And then I can kind of go from there. And that's what my graph is going to look like. So my final answer kind of looks like this. Sorry, my lines aren't super straight. It's a problem I have. I'm trying my best. Okay, let's keep going. Okay, in red, I'm going to kind of do this one all at once. It's got the same shape as the parent function, except it's upside down, right? And it's been shifted twice. It's been shifted to the right 2 and up 6. So I can just take my vertex, this point, right? And I can go to the right 2 and up 6. Put my vertex, and then have that opening down. You could draw each stage if you wanted to do that first. That would also be fine, but it's also perfectly acceptable if you can kind of do all of them at the same time. That's what you should do. All right. It's looking good. -2, we went to the right 2, up 6. Hopefully I counted correct. Same shape as the parent function. Yep, double checking my work. That looks good to me. All right, let's keep cruising. Uh-oh. Now we got a couple other things that have happened. So I'm going to do this in stages so that you can see the transformations take place. If you were to plug a number in for x, the first thing we'd do is subtract 2. That means that's a shift to the right 2. The next thing would be you'd take the absolute value and then multiply by 3. So first, we're going to do the shift to the right 2. Then we're going to do this thing corresponds to a vertical stretch. So this is a vertical stretch. And we are stretching everything to 3 times its height. But that's going to happen second. So here's my parent function. Dot, 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 dot. You can imagine what it would look like if I connected these dots to get my V. All right, and then I'm going to take these dots and I'm going to shift them to the right 2. So here's my shifted graph to the right, just like so. And then next, so that this shifts them to the right. The next thing I'm going to do is I'm going to take these points, right? I'm going to do this thing in blue. These points, and what I'm going to do is I'm going to triple their heights. Triple 0 is still 0. Triple 1 is 3. I can reflect it because it's symmetric. Triple 2 is 6, and at this point I'm heading off my coordinate plane. So I'm done. I'm going to connect them. So we got our V. This is a steeper V. Man, that's fun. Okay. Math is fun. Oh no, we have more? Look at all these. What a disaster. Just kidding. These are fun. These are fun. I love these. It's like putting together a puzzle, one step at a time. You got to collect your pieces. That's what we're doing right now. We got our pieces laid out on the table. We're going to start shifting stuff around. Okay. All right, follow the order of operations. What happens first? All right, well, we got the negative, so we're now going to be opening down. We also have this 1/2. So really what's happening is I'm actually going to think about graphing y equals 1/2 x first, and then I'm going to flip it so we understand what that is. What 1/2 x looks like is it's all these dots that go to half their height. Half of 1 is 1/2. Half of 2 is 1. Half of 3 is 1.5. Half of 4 is 2. It also, just for absolute values, it also is kind of half of 0, 0. It's just the slope. Okay, now we can take all those dots. We can take all those dots and we can reflect them. We're going to reflect them over the x-axis, so our new graph is going to look like this once it's flipped. Oh, it's beautiful. Okay, so here I have the parent function. I've shrunk everything, I've compressed everything down to half its height. And now I've reflected it. And now I take all these red dots and I shift them up 3. So I'm going to do this. What, did I just select a new color? No, I didn't. Pardon me. In green, we're going to do our final equation here. I don't like that it's covering up the 1/2. There you go. We can see it a little bit better. All right, take all these, shift them up 3. 1, 2, 3. Put a dot. The process continues. You can kind of see that unfolding. So the one that I'm interested in, I'm really not interested in these dots. You don't have to show those. In fact, I really would appreciate if you just drew them really lightly or erased them. I don't want to see, you can draw these really lightly, but the thing that you connect, so I should never see two finished absolute values drawn on your graph. I want to see them, I want to see the one that's complete is the one that I'm going to grade. I don't want to see a bunch of lines connected together. All right. Fantastic. We're supposed to find the domain and range of these. Let's do that real quick. Forgot to do that. All right, let's just do domain for the first one. Domain is from, it's going to continue forever that way. Continue all acceptable x values should be from -infinity to infinity. You can save yourself some time by writing this symbol. This means all real numbers. Okay, the range, the lowest possible y value is 0, and there is a point that has that value, so we can include that. 0 up to infinity. Okay, how about for this next one? For part B, domain, again, is -infinity to infinity, all real numbers. And the range, what's the lowest possible y value? There is not one. It continues forever in the negative direction. And then it goes up to a maximum of 5, which is included. Okay, and lastly, all reals for the domain. And the range, lowest, there is no lowest, so -infinity up to 6, which is included. This is fun. All right, let's keep going. All right. Ooh, and okay, let's do this last one real quick. Let's do the last one. We'll do this one in red. Now, I taught you a trick on the last section. If you need to go review it on day 1, I would encourage that you do. When you're graphing one that looks like this, if the coefficient on the inside of the absolute value is anything other than 1, you need to make some adjustments to the inside. And there was this rule that I taught you where I said y equals if the absolute value of product, that's equal to the product of the absolute value. So what you do is if you have this if you have these two things, typically you're going to have a common factor. So you just have to factor out or undo the distributive property of the two terms on the inside and then get this into simplest form. So what that looks like is this is going to look like the absolute value of 2 times x plus 2. So each of them have a factor of 2, so you're kind of dividing each term by 2. And then what you can do is, since we now have a product, we take the absolute value of 2 and you end up with 2 times. So I'm applying, from this step to this step, I'm applying this rule. 2 times x plus 2 minus 6. Okay, so we've just taken this horizontal change on the inside and we have turned it into a vertical change. So, all right, cool. So my vertex, first thing that happens is it shifts to the left 2, then doubles the height of all the points, and then gets shifted down 6. So we can do this in stages. You can kind of do it all at once. I'll let you try it. Your final graph should look like left 2, down 6, and then the slope is going to be twice as steep as the parent function, that y equals absolute value of x. So basically, normally I go up 1 over 1, now I'm going to go up 1 over 2. Normally I go up 2 over 2, now I'm going to go up 2 over 4, so on and so forth. So we can repeat this pattern and create a v for value. Okay. It's gorgeous. I spoke too soon. Careful. Okay. There you go. Beautiful, 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 beautiful. All right, cool. It's asking us to find increasing and decreasing, so let's do that real fast. Increasing from this, for this region, is going to be from 2 up to infinity. So remember, I'm looking for the x values where it is increasing. Increasing means as we go from left to right, we're going uphill, right? So for all these values forever continuing that direction, we're going to be going uphill. And decreasing is from negative infinity up to 2. All right, these other ones I'll let you try. I'm just going to do them real quick to say we did. Increasing. I'll make sure to breathe really heavy in the microphone. Up to negative 2. Super. Awesome. Let's keep going. All right, so we have a couple rules here that we can kind of refresh on, feel a little bit better about. We've already done all this stuff. If you look at these previous videos, remember, we can kind of recap. Any addition or subtraction that was on the outside of the absolute value bars shifted our graph up. Well, if you have any function, it doesn't matter what the function is. If you add a number to that function, all that's going to do is take the graph and shift it up k units, right? It's going to take it and it's going to shift it up k units, which is what we did right here. We added 5, it went up 5, right? We added 6, it went up 6. We added 3, it went up 3, so on and so forth. Takes the whole function, shifts it up k units. So subtracting is going to shift it down k units. Now, if you change the x value, on the inside by adding a number, effectively what that does is it's kind of like shifting the perspective of where you're looking on the graph. And it kind of does the opposite of what you would think. So basically, when you add k here, that actually shifts to the left k on the graph if you're adding a number to x, and if you're subtracting, it shifts the whole graph to the right k units. And when And for this one, when you're if you take a function, so like x squared, right, and you multiply it by 2, what you're doing is you're taking all of those values and you're doubling their height. So when you multiply by something that's bigger than 1, this results in a vertical stretch by a factor of a. So whatever, so if it's 3, we triple the heights. If it's 2, you double the heights of all the points relative to the x-axis. If they're below the x-axis, then you double the distance in the opposite direction, right? Okay, and if a is between 0 and 1, if a is between 0 and 1, then this corresponds to a vertical compression. Means it's getting squished down, vertical compression, squished down by vertical compression. You're going down, whatever. Basically, it's like multiplying by a, right? So you take a, you multiply the height. So if it's 1/2, you're going to go to half the heights. If it's 1/3, you go to a third the height, so on and so forth. It's vertical compression. Explain how each graph is obtained from the graph of f of x. This is really easy. F of x minus 2 means a shift. Whoops. Shift. This is a shift to the right 2 units. What about this one? It's outside. This is on the inside, so it's left, right. This is on the outside, so it's a shift up. Nope. Take that back. I was testing you. Shift down 3 units. Inside goes the opposite, the way you think outside behaves normally. And this one has 2 different transformations. The first, the negative, is a reflection over the x-axis. Oops. And you really could add that to your notes on this page. If a is less than 0, we reflect over x-axis. Okay. And there's a second transformation that occurs. The second one is a shift positive outside, which is up 5 units. All right, so you can approach problems like this in 2 ways. So it's saying, here's our function f. Can we match these numbers to the ones over this? Pause the video, give it a try, see if you can do it. If you can't, then we're going to walk through it anyway. So here we go. Let's take a gander. F. Here's f, right, going on right here. So you can do it 2 ways. You can look, like, we'll do the first one by looking at the graph and trying to figure out what's going on. So let's say here's f, and it looks like this is the exact same shape as f, right? It's the same shape, it's the same orientation, it hasn't been reflected, it's just been shifted to the right 1, 2, 3, 4 units. So left, shifting to just to the left or right means there's a numerical change on the inside. We're adding or subtracting something on the inside of the function. Okay, so that means this has to be graph 3 because we have moved to the right 4, that minus 4. Okay, f of x plus 3, this just means it's been shifted up. That's the only change. Well, number 1 is the only graph that is the only change has been shifted up. The other thing you can do is you can come over here and you can start kind of reasoning out which one is which based on what you see. So for example, you can look here and say, oh, this one is the only one that has a negative in the front, which means, you know, it's been reflected. So there's one of those that should be upside down. Okay, it's this one. This one is this graph reflected, I did a bad job, and then shifted to the left 4, right? That's what that looks like. So that's got to be graph 5. Okay. Whoops. I tried. Epic failure. Okay. Let's take a look. This one looks like it has, since A is bigger than 1, it had a vertical stretch and then it got shifted to the left. So everything got doubled. The heights got doubled and then everything got shifted. What the hoogie? Hold on. There we go. The heights got doubled and then it got shifted to the left. So if you double all the heights, that point goes to there. This point stays here. This is at 3. That would go up to 6. So the graph is going to look something like this. Well, that's exactly the same as this, except that's been shifted to the left 4. So I think we just found what we were looking for. We did find what we were looking for, you two. Deal with that. So that's graph 2. By the process of elimination, this has to be graph 4, but you can reason it out. Everything is 1/3 its height. This was up at 1, now it's down at 1/3. This was at 3, now it peaks at 1. This is at 0, 1/3 of 0 is still 0. So this is graph 4, and that 1/3 is the dead giveaway there. All right, let's keep rolling. Uh-oh, I'm out of focus. Okay. Oh, look at this. We just got a couple of these left. So we got a couple functions here. Yep, that's pretty easy. We got a couple functions here. We're going to talk about the changes that take place. And I'm going to kind of give you some strategies for taking a function like this and manipulating it based on the transformations that we're given. So you should be able to look at the function and know exactly what's going on here. So this function is has this -3. The only transformation is the -3 on the inside. So what we can do is, this means it's been shifted. So inside opposite, it's been shifted to the right 3 units. So I'm just going to pick a point of reference. I think this is a nice, easy place to start. So here's my graph. It looks like it crosses as a y-intercept of a 4. So I'm going to cover over here, and I'm going to use that as my reference point, right? So here's where that point is. Now I'm going to take that point, and I'm going to shift it to the right 3 units. Now what I'm going to do is, I have that reference point. I'm going to use that reference point to draw the rest of the shape. So this is the point I shifted over to 3. So now to draw this line, I go down 4, over 4, put a point, connect those lines. Why is it showing the eraser? High quality software here, folks. Then I go down 3, over 2, connect the dots. The points. It's like, well, you're a math teacher. Jeez Louise. You're using like baby language. There we go. And then come up this way. Perfect. So we take all those things, shift them to the right 3. That one's pretty straightforward. Let's do the next one. This one has 2 transformations, right? And so what order do they happen in? Think about this being a number. What would you do order of operations wise? You'd make it negative, then you'd add 2. You wouldn't add 2 and then make it negative. So you have to follow those operations. All right. So again, I've got my reference point. And then you can go through, we're going to reflect, right? There's 2 things that happen. There's a reflection over the x-axis, and then you add 2. So first things first, I'm going to actually just draw my parent function. Why? Okay, whatever. I'm over it. So my parent function, the reference points down 4 over 4, and then I go like that, and then like that. I have those kind of, these reference points kind of figured out. So I'm just going to lightly, man, that looks pretty good. I'm going to dot this. There's my, this is kind of the parent function, the starting function that's being manipulated, right? So then what I'm going to do, this is not written anywhere. This is f of x, right? I'm going to take that function, and the first thing I'm going to do is I'm going to reflect it. So I'm going to take, in purple, I'm about to graph y equals negative f of x. Try that again. Negative f of x. So I'm going to take these points, I'm going to reflect them over the x-axis. That's on the x-axis. So you don't need to do anything there. Reflect, reflect. This is 2. This is 1 away. This is 4 away. This is 2 away. So you have to make sure it should look like a mirror, like it's been mirrored over that line when you're done. Okay? Should look like that. Fantastic. Fantastico. Okay, but we're still not done because we are interested in our final graph, which is this purple graph, but everything shifted up too. So now I'm going to do that. This is our final answer. All these points get shifted up to, up to, up to, up to, up to. And then now we can connect them together. We can connect them together. Okay, done. Beautiful. Beautiful. Okay, this one's a little harder, but not too bad. What do we do first? Following the order of operations, if you were to plug in a number for x, you would subtract 1, then send it through the function, so to speak, right? So we're gonna do the inside of the parentheses first, then we're gonna do our vertical stretch. So here is our vertical stretch. The 2 gives us a vertical stretch. This gives us a shift 1 to the right. So I'm going to take my parent function. Oh, what the heck. I'm just going to first, I'll draw f of x minus 1. So I'm going to take that and I'm going to shift stuff to the right. 1. Okay, so there's my parent function shifted to the right 1. Now I'm going to take all of those. Now for my final magic trick, I'm going to saw Tim in half. I'm kidding. I'm going to double the heights of all these points. So double 0 is 0. And right now I'm graphing in green this thing. Double 0, 0. Double 4 is 8. Double 1 is 2. Double 2 is 4. So I've doubled all their heights. How did I do that so what is wrong with me? I can't draw like baby lines straight, but I can do these marathon lines. Okay, and then there's our graph. So we shifted it to the right, and we doubled the heights. And that's it, team. That is all for today. Thanks for watching the video. This has been 1-2 Transformations Day 2, the sequel. And there's going to be more content coming from my channel, coming down the pipeline, the internet superhighway, the information superhighway. I forgot what it's called. Anyway, see you next time.